Hi, my name's Christian Flotter and thank you so much for joining me today. Today I'd like to take a bit of time and talk about the pathophysiology of the COVID-19 virus. I know it sounds rather intense, but you know, what's that old art of war saying, know your enemy? When you understand how it infects you and how things happen, you can counter-effect that one much more effectively. So let's get into it. So first up, COVID-19. It's a droplet-based disease, but droplets can also exist in the air. When you sneeze, for instance, sneezing, I love this one, it comes out of our mouth at about 145 kilometers per hour. So it's not a very slow speed. And these little droplets, they are now airborne, okay? But they're not like, it's not an airborne virus, it's an aerosol. So it is a droplet suspended inside the air. Now, this droplet can either get straight in, or it can land on a surface. We can then touch that surface and then touch ourselves, and the next thing we know is we've transmitted that virus to ourselves. Now, the good thing is we've got a first layer of defense. Now, this first layer of defense lies inside our mouth and our nose and our throat, and it's a part of our mucosal membranes. See, over the top of these mucosal membranes, we form a layer, and it's a layer called secretory IgA. Now, this SIgA is incredibly effective at picking and choosing. It can grab a little bit of virus and it can help develop our immune system against that virus. And it helps to protect us from having things go down further into our system. I've spoken about our IgA previously and how probiotics can be very beneficial when it comes to creating this layer. Now, if we don't have this good layer, down she goes, straight down to the alveolar region of our lungs. So the alveolar region of our lungs, this is the point where we do a lot of our gaseous exchange. So our lungs, the main thing that we think about them for is to absorb oxygen in from the air and to expel carbon dioxide back out again. But this happens in the alveolar region. So once the COVID virus gets down inside our lungs, it starts to attach to those type 2 pneumatocytes within the lungs themselves. So type 1 pneumatocytes, those are the ones that are involved with gaseous exchange. Type 2s, they're involved in producing this layer known as surfactant. Now, surfactant helps to keep everything there all together safe, and helps that transmission of gas across. See, gases diffuse better when they're actually absorbed onto a liquid thing that our body can then work with as opposed to through the air. Now, they attach to these type 2 pneumatocytes and they cleave themselves and insert RNA. See, the COVID virus is an RNA-based virus, and this little RNA, it swims through the cells till it gets to the ribosomal region, where it then tells that cell to make more of that RNA and more of the protein that creates the housing of which the virus transports itself around in. Now, this is where the fun stuff starts to begin. See, once the cell's attacked, it starts releasing these things called cytokines. Now, these cytokines attract our immune system towards that cell to help get rid of whatever it is that's creating an infection or an aggravation. The cells that come around, they're Th1 cells, macrophages and neutrophils, essentially the Pac-Man cells of our body. They come along and they eat up the bad guys. Now, when these guys start coming in, they start doing their thing, they also start releasing their own cytokines. Now, this is when the party starts to become really quite adventurous. See, when macrophages and neutrophils start releasing their cytokines, they typically release interleukins 1 and 6. Interleukins 1 and 6 begin to attract another subtype of immune system cell known as the Th17 cell type. Now, when Th17 is involved, this is when the party really gets started, okay? And it's in fact this stage that we start to see the more severe symptoms of the COVID virus really manifest. So why is that? Well, Th17 creates two effects inside our body. Firstly, local to the lungs, but also outside of the lungs. And it's in fact, this is where vitamin D is of utmost importance. See, vitamin D helps to downplay the impact from Th17. Th1 is great. We want that one happening because it's going to get rid of the virus from our lungs. But once Th17 kicks into place, that's when it starts to become a little bit more complex. Okay, so locally in the lungs, what starts happening is this Th17, it creates a permeability. Things begin to dilate. Things are easier to go in and out. And what happens is the fluid from inside the cell starts to go outside the cell. and it goes into the area where gas exchange is meant to be happening, inside our lungs. We start to develop and produce phlegm. Okay? When this virus joins that phlegm, we cough it up, we spread more COVID virus around. Our lungs stop working effectively, so we need to start breathing quicker. We need to start using other muscles to help us with our breathing. We'll start utilizing accessory muscles instead of our diaphragm. Now, when we've got this dilation going on, the virus is now able to spread to other points inside our body. And this is where we start to see what's called as the systemic effects. And this is courtesy of these cytokines. Now, when these viruses express or spread out to other parts of our body, other cells can start releasing their cytokines as well, which creates more cytokines and more cytokines. And we end up with a process known as a cytokine storm. Now, this is a more serious sequelae of what's happening with the COVID virus. So now we've got a virus that's circulating inside our body, and once it reaches certain parts of our brain, we can start to see other impacts as well. See, once it's gotten to the brain stem, it can now influence heart rate, it can influence blood pressure. Because we're breathing very quickly, our heart rate tends to go up as well. But at the same time, because of this vasodilation that's going on, it drops our blood pressure. Once it gets up into the hypothalamic region of our brain, see the hypothalamus, that's the region of our brain that's involved with thermal regulation. Once it reaches this hypothalamic region, that's when we start to show up signs of a fever. Now, the most serious aspect behind this COVID disease is when it starts to influence the function of our liver and kidneys. When we don't properly function in the liver and kidneys, that actually increases our risk of more stuff going into our bloodstream. Now, if this continues on, we can risk going into septic shock. Now, septic shock is a serious and severe complication of the COVID infection, but that doesn't mean that everybody's going to be getting that one. The majority of people actually just have mild to moderate symptoms of the COVID infection, and it's a very small percentage that will require this type of intervention because of sepsis or respiratory distress. What we do need to be careful of is that it's more so the elderly and more so the immunocompromised, those who have got pre-existing autoimmune conditions, those who have got ACE inhibitors or weak hearts or weak respiratory systems or previous existing respiratory damage. These guys are the ones who are at higher risk of something serious occurring. But we can still take things to reduce our risk of this happening. So please look at taking the probiotics, look at taking the vitamin D, as these may help to reduce the risk of you progressing further with this disease. Now, at the same time, we need to be sensible. Listen to the government's recommendations. Social or physical distancing is actually of benefit, because when I sneeze now, it's not going to make it to you. Okay? So if we have this social and physical distancing occurring, it's going to reduce the risk of this actually transmitting and getting into our systems. I hope this has been informative for you. It's quite a complicated process and it's quite a complex situation that I've tried to jump into one very short little video. But if you have any further questions, I'd be more than happy to answer them. Just shoot me through a message or a little reply, anything. I'd be more than happy to help out. Otherwise, keep well and keep safe. I'll speak to you again soon.